guys like Swedish wine? Because the chances are Sweden will be one of the emerging wine regions of 2050 based on the trends in rising temperatures. My name is Deniz and I work with clean energy technologies as a PhD researcher at KTH. And today I want to talk about the nemesis of our civilization, carbon dioxide. The world is now switching to net zero emission goals in order to limit the rise in temperatures. However, much of the world is still operating in the old ways. For example, since the beginning of COVID-19 crisis, a total of $200 billion were invested in fossil fuels. If we operate in this existing energy structure, our climate goals are far from reach. Power plants and industrial manufacturers are still the main contributors of carbon dioxide emissions. And let's face it, our dependency on carbon-based energy and goods won't go away overnight. And it takes time to transform these industries at a global level. This brings us to the question, how are we going to get these guys to play nice? Or let me rephrase the question. How can we monetize carbon dioxide so that those who don't play nice are motivated to capture or recycle it? The problem with carbon dioxide is that it's a tough player, and it's very expensive to separate it using the conventional carbon capture technologies. And there is a big barrier to chemically tweak it out to make things out of it. Electrochemistry offers us an efficient path to skip the old beaten track and turn carbon dioxide into a raw material instead of waste. I work with a special type of reversible fuel cell that uses molten carbonate as the magic ingredient. The reversibility and the carbonate content is what makes the technology the silver bullet of carbon dioxide separation and recycling industry. In the fuel cell mode, the cell can separate carbon dioxide to high concentrations while producing energy. In the electrolysis mode, the cell can produce hydrogen and valuable chemicals from the exhaust of, for example, a power plant. For my PhD work, I concentrate on the electrolysis orientation of the cell, working with the exhaust from a biogas production plant. The idea is to reduce the content of carbon dioxide and water from the exhaust gas. While doing this, we're discovering the abilities of this technology to make it a key player for the carbon dioxide separation and recycling scene. Through the results of our work at KTH, we will configure the prime performance of the fuel cell for carbon dioxide applications. Scientific knowledge of the cell and carbon dioxide separation orientation can help us make it become a demanded technology to reduce emissions effectively and affordably. Together with future industrial partners, we can use molten carbonate fuel cell to reduce point emissions significantly by monetizing carbon dioxide separation and recycling. And that's how we make them play nice.